Hello, hello everyone. How is everyone doing today? Hopefully everyone's doing well. I'm seeing a lot of good stuff in the chat. Everyone's saying hi. Hello, Quackers and Cheese. Hello, Sherlock Holmes. Hello, Mandy. Um, Hello, Silver Acid. Yes, it is me again. I'm so glad you're here. I saw you actually at my workshop yesterday, or it was yesterday for me. I don't know what it was for you, but that's awesome. It's great to see that you're hype about all the different workshops happening this week. I know it is Cloud Week, but there's still a lot of AI and ML just because that's, that's a big hype thing right now. So I'm glad you could make it. All right. Um, Before we get started, there is like a little exercise or like a fun thing that I like to do is just know where everyone is tuning in from. So where in the world are you tuning in from today? And just let me know in the chat, wherever it is, just so I have a good idea of how international the audience is. All right. Mandy said, I worked on that thing until 2:30 a.m. and never got it finished. What was the thing that you were working on until 2:30 a.m.? Okay, Southeast Missouri, very specific. Okay, that's awesome though. So we have some, okay, Missouri in the house, Raleigh, North Carolina in the house, a lot of US. Anyone who's not in the US, I think the furthest person we had yesterday was either all the way out in Australia or Sri Lanka. Um, we have NorCal as well. Okay, Sunny's coming in from NorCal. Soham asked, "Hey, is this stream related to yesterday's stream? Because I'm from India and I slept and didn't attend it." No, this was a completely different stream. This one is on actually creating ML models and then deploying them to the cloud. So again, you need no prior context of anything that happened before this, right? You can be joining in completely new, and that is perfectly fine. The AI chatbot with me. Oh, that you were working on until 2:30 a.m. Reach out to me on Discord, and then we can get that working together. I know that is also something that I need to fix. I think there were a few errors in just the deployment steps, so we can easily figure that out, and then I will update the GitHub, and then you should have everything working, running, and good to go. Yeah, you're welcome. All right, 404 not found. A very, a regular at most of these Global Hack Week streams. Hello, hello. It's great to see you back as well. So a lot of familiar names and familiar Twitch usernames. I love that. All right. So we have a good idea of where everyone's from. Looks like it's majority US based, so that is, that's great. But all right, let's dive right in. So, little introduction about me. If if you don't know who I am, I'm a coach at Major League Hacking. I've done a lot of these streams before. I'm seeing some of you in the chat that have been to my previous streams, so you know. Looks like we have some new people that are also joining us as well. Hello, hello. But I try to keep all the streams very simple, very beginner friendly. And again, it's super open. If you have any questions at all, no matter what it is, just put it in the chat. I will do my best to answer them. I try to make things as easy to understand as possible and explain them as well as possible. But sometimes, some things aren't as clear as they can be. So please do let me know if something doesn't make sense. And I'll do my best to circle back and answer that. Um, Today. Hopefully, I'm a little bit better about sharing my screen. I know yesterday's stream was a little problematic because there were a couple times where I forgot to do that, but hopefully we have it down on lock today. Oh yeah, so a little bit about me. I'm a coach at Major League Hacking. I've been a coach for a while. I've been to a lot of hackathons. Currently doing my master's in artificial intelligence, actually. So this is a topic that's very near and dear to my heart, right? So yeah, we can actually dive right in. Let's see. We have a few more questions. What happened to the earlier stream of simulate an IoT remote control system at home, part one? That is a good question. I'm not sure when that was supposed to happen. I do recommend checking out the Global Hack Week calendar. Actually, let me do this with everyone. That way we have a good idea of how this works. This is sort of how I keep track of what time everything is at, just because it can be very difficult to know what's going on where. Let me share this. So Soham, good question. Normally what I like to do is I just take a look at this ghw.mlh.io/schedule, and that should have the full schedule on there. Um, and what you can do is open up like over here. Okay, so for me it's at 6 p.m. CT. So it shows you what it is in your local time over here, and you should be good. And this is simulating IoT remote control system at home. It is currently, and again, this is just showing whatever your local time is. Um, right now, we are doing AI model training and deployment on the cloud. For some reason, half of these are in GMT and some of these are in CT. I think that's an error on just the website's end. I will actually put in a request to get that bug fixed. But again, you can just click on one of these and it should open up something like this, and you can just add it to your calendar. So if you click on like the Google Calendar button or the iCal button or the Outlook calendar button, whichever one you use, just click on one of these and you should have, you should have it on your calendar. So I would recommend doing this. Again, it is probably the best way to know what's going on when, especially because everyone's all over the world, and it definitely can get confusing on what's happening when. Okay, see if we have any other questions. Oh, good. Hello, hello. I remember seeing Ilyast in yesterday's stream as well. And yeah, so it is in about 4 hours. Again, you just need to check the whatever's after the time. Is it GMT? That means it's international, or if it's like wherever you are in the world, PST, CST, whatever it might be. Google Calendar and schedule disagree. They should not disagree. There might just be an issue with like again the GMT versus your local time, but it should be synced up though. Sherlock Holmes asks, do we need a cloud account for this one? You should not need a cloud account as far as like a AWS account or a GCP account is concerned. Today we will just be exploring the different cloud options, and then we will be doing most of this in Google Colab, and then I'll be giving sort of an example of other sort of GPU cloud providers and how those work and how they compare to Colab. Mandy said that's what you wanted to specialize in, but not available. So master's in applied computer science. Applied computer science is also pretty important. I think that is, yeah, that is actually, I think, one of the, or some of the closest you could get to AI. So that's good that you are, you're doing a master's in applied computer science. That's really good. All right, Logical Llama said, been enjoying the streams you've been able to catch. All right, glad you were able to do that. Wondering where you can find videos of yesterday's streams. You can go to the MLH YouTube. So that's youtube.com/Major League Hacking. Then they should have like a live section, and you should. Oh, I'm seeing myself here. That's kind of trippy. But let me just copy and paste this, and this will just take you to all the streams that are happening at the time. So this should give you all the live streams that are going on. And okay, yeah, it looks like Soham already did answer that. And what is the agenda of this stream? All right, I guess we will get right into that. Let me just get through the final questions, and then we'll jump right into the agenda, what we're doing today, and then actually do it. It'll be pretty great. Mustafa asks, how can you check in on each live session? I think by check in, do you mean check into the event? For that, you'd need to go to the schedule, and then you can open up whichever stream you actually want to check into, and then that's how you check in. So you click like login and register, and then you just register for the event first, then you could check into the event after you're registered. All right. Compom said couldn't proceed with the AI chatbot because the IAM and AWS way behind the credit card paywall. Yeah, that is an issue. Specifically with AWS, they just do that for verification purposes so that you're not getting a bunch of bots. But today we will not be needing a credit card for sure. I like triple check this time so that no one's going to need to use a credit card for we can all do. And then I'll be showing some other options that might require credit card. I think I put like $20 on a cloud GPU provider, $25. So that's just to show you all. That's not something that you need to do. It's just something that is an option for you. Um, and yeah, so I answered the question on how you can check into each session. The link was posted. I can post it one more time just so everyone has access to it. So this is the link to check in. And let's see. Mandy, yes, do we need to download any software? For this, you will not need to download any software. We'll be doing it all on Google Colab. So you do need like a Gmail account or Google account, but that's it. And then Psalm S, so now only Node.js was asked to install. Yes, so everything is going to be done on the web today. So we should be completely fine. All right, it looks like I got through all the questions. That's great. Awesome questions, y'all. Again, just keep them coming. Hopefully I cleared up any misconceptions or any other questions you might have had. So let's actually dive right into what we're going to be doing. So at a really high level, today what we're going to be working on is just creating an AI model and then actually deploying it to a cloud provider. So we're going to start off, obviously, we just had like a open Q&A pretty much, going to dive into a sort of introduction and just figure out what the objectives for our stream today is. Then we're going to go into the fundamentals of training this AI model and then actually write the model itself. So we're going to write the model from scratch. That way we understand what's going on underneath the hood. And once we do that, we're going to deploy it. And it'll be a sort of hands-on session where we're all coding it together. And then we can deploy this model. And once we've deployed this model, we'll compare it between different like cloud providers, see how these different cloud providers compare. And yeah, that should be pretty much it at a very high level. Again, if you do have any questions, please do let me know. All right. So jumping right into it, right? We are basically just doing AI model training and deployment on the cloud, which is going to be very hands-on workshop. So you're just going to be building an AI model and then deploying one using some cloud service. So you might be wondering why we're going to be using a cloud model and maybe not a local model. Well, other than the fact that we are in Global Hack Week cloud today, right? Or this week. There's also a lot of other reasons why you might want to use a cloud as opposed to local storage, right? AI models generally require a lot of computational power and storage. And this is especially happens when you're dealing with like deep learning models because those are very power and processor intensive. So if you're running everything on a personal computer, you'll need a really nice, really expensive computer. Or if you're using like a slightly older one, it might take a long time for you to actually train your model. So what we can do is just use cloud platforms for scalability. So we can actually run larger models without the hardware limitations that we might have. It is much more cost efficient, right? You don't have to buy for a ton of hardware that you're only using maybe once or twice. You only pay for what you use instead of you having to actually purchase and maintain expensive GPUs and other expensive hardware. And it's a lot more accessible, right? You can actually train AI models from your phone or train AI models from any laptop instead of you having to have like a crazy, rig to actually train anything locally. So again, today we're just going to be training an AI model from scratch, and for that we're using PyTorch. And then we're going to be using a cloud GPU for more efficient training. So specifically, we're going to be using GPU on cloud, and then deploy this. And hopefully at the end, you'll have a fully trained AI model that is up and running on the cloud. All right. So for the key frameworks, tools, and technologies that we're using today, we're going to be using PyTorch. And for our cloud service, we are specifically we'll explore a little bit of Google Vertex. Um, Actually, no, I don't think we can use Vertex because my credit card got denied on there. All right, so we'll probably use, we'll just use Google Colab and check that out. Then we will compare that to RunPod. All right. So next, we're actually going to get more hands-on by actually setting up our environment and then training our very first cloud-based model. All right. Hopefully everyone is ready to build. Yeah? Yes. Okay, awesome. We do have one question from Soham. Came across Hugging Face but was unable to understand what it was. That's a good question. So Hugging Face is almost like a repository for models. So if you know how GitHub is sort of a repository for code, it's very similar to GitHub, but Hugging Face is, think of Hugging Face as like GitHub for AI models. That's specifically what it is. So if you wanted to use like a pre-trained AI model like a llama or some other offshoot of that or any other AI model, then you could go to Hugging Face and get a specific or a model for your use case specifically. So there was one, there's something that I was exploring earlier actually, on sort of creating those avatars. You might have seen one of those AI apps that create avatars of you. This is sort of an example of one that you might get off of Hugging Face. You could get a model that takes a picture of you and then converts it to an avatar. So it can be one, you can have one of those sort of uh, models up on Hugging Face. And then there's a lot of others, right? Any of the open source models you can probably find on Hugging Face, like DeepSeek's model or the Llama models. Good question. All right. So honestly, we can jump right in and get started. So what I need everyone to first do is create a new notebook on Google Colab. So I'm just going to move this over here. And we are going to be using Google Colab today. So I'll open that up. And let me get that opened up as well. Colab.research.google.com, new notebook. And again, if anyone does have any issues doing that, please do let me know. And let me share this. So the first part of this is going to be a lot of sort of just model creation, right? We're going to be creating our model from scratch so that we can really understand what it's doing and how it's working. And then we will uh, be able to, or it will technically still already be deployed on the cloud, right? So Google Colab is actually a cloud GPU provider. So we'll actually see that shortly. Actually, we could see that right now. So you can see that over here. This is sort of what your Colab screen should look like. Good, I am sharing my screen. So this is what your Colab screen should look like. And what you'll want to do here is click connect, and this will connect you to a runtime. Initially, it'll try and connect you to a CPU, just because that's a lot less intensive for them, right? It costs less money for them, but we do not want to use a CPU. So what you want to do is actually click on this change runtime type. And then once you change, you can change it to a T4 GPU. It'll disconnect and delete this specific runtime, but now you'll be connected to a T4 GPU, and that is significantly more powerful than the CPU that you would have been using otherwise. And then you can just save that, it'll connect to it, and then you should be ready to start coding. Um, so Mandy asked, how do we set it up? So it should look something like this. We will be walking through the actual code part of it as well. But initially your setup should look like this. So the tab is, if you go to colab.research.google.com, let me go here, then you can either create a new notebook over here, or I'll be using this one right here, GHW Cloud, because I've already created it. And then that will open up a new notebook that looks something like this. So resources tab, you can go to either runtime over here. So there's two ways to get there. You can get to runtime, change runtime type, and then that will give you the option to select a different GPU or change from CPU to GPU. So this is what we're going to be doing. All right. Get more visible. Okay. So now that we've done this, hopefully we can get started with the actual coding part of it, right? And this is going to be, I wouldn't say lengthy, but there is going to be a lot that goes into it. So it is important to, I wouldn't say pay attention, but I will be uploading all this to GitHub. But I would recommend, just knowing how everything works because it is helpful. So and at first, obviously, we do need to import a bunch of stuff. So for us, we can start with importing OS, import torch, import torch.nn as nn, import torch vision dot transforms as transforms. What else might we need? Torch vision datasets dot datasets as datasets. Oops. And then import from matplotlib dot pyplot as plt, import numpy as np, import torch summary, and let's see, from torch utils data import data loader, and then we don't need any of this, but we will need from torch.amp import. We need autocast and gradscaler. Okay, so these are all of our import statements. Again, this is probably the most, most you need to type for just things you have no idea what's going on for, because this is kind of blind. I'm just kind of saying, trust me, you will be using most of this. So again, these are just all the import statements that we're using. And then next up, we will actually start working on creating our neural network. So sometimes it shows you have too many active sessions. That means you just have an extra session running. So if you go to, you should be able to terminate one of your open sessions, because it does only allow you to use the GPU on one notebook at a time. So you might have been using Google Colab and forgot to disconnect the runtime or disconnect the GPU from another project that you're working on. And then, Mandy asks, what runtime are we using? We are using a T4 GPU. So you can go to change runtime type, and then the T4 GPU is the hardware accelerator, and then Python 3 for code. Okay, hopefully that answered the question. And next, we can go right into coding up our neural network. So for this, we're going to create a new class. So class deep neural network. And for this, we are passing in a neural network module. And then init, we're going to write our init function. with pass and self, super deep NNN, and self.init. So we actually initialize, and now we're just going to be writing the different sort of layers that are going to go into our network. And I'm actually going to type these out first so that you all can catch up and then sort of explain what's going on once I have them written out. So self.convolutional neural network. So this is the first layer is nn.conv2d with in channels of 1 out of 32, kernel size of 3, stride of 1, and padding of 1. Okay, that all looks correct. Same thing here with in of 32, out 64, and then 311. Nut pool. And this is a max pool 2D, kernel size of 2, stride of 2, padding of 0, and then two linear layers, 64, 7, 7, and 128, and then 128 to 10, and then ReLU. Okay, so that is our neural network. And then we can write a forward network of, what is this? Self.pool. Self and X. Let's and then X is self.pool, ReLU, conv2. View of X.size and -1 here. Self.ReLU of S1 and to return X. Okay, there we go. So Psalm has statements here serve as sort of template, like they're common for many kinds of projects, or do you have to have a deep knowledge of these? So this is kind of a sort of template. So specifically, this will depend on the data set that you're using. And I'll be getting into what data set we're using shortly and what everything is for. So honestly, why don't I get right into that? And do we have any other questions? What does common mean? Okay. Yeah, so essentially what's going on here is for the deep neural network class, right? This just is defining a deep neural network over here for image classification specifically. So the problem that we're trying to solve today, or the machine learning algorithm that we're using today, is for recognizing handwritten digits. So you might have seen some videos or some other examples of this, where you're recognizing what sort of what hand digit number is written and what actual what does that output to, right? So I've got so much going on here. Okay, yeah, so what does that output to, right? So essentially we have our convolutional layers, our pooling layers, our fully connected layers, and then our activation function over here. So you can see at the very beginning we have this sort of init method that's going on, and that's just a constructor of the class, and we're just executing that when the object of the class is created. So nothing too special going on there, just basic sort of Python. Um, stuff happening. And then we are calling super, right, to actually call the constructor of the neural network module. So that's the base case for all the neural networks in PyTorch. And this basically is making sure that the functionality from the neural network is included. So then we have our first convolutional layer, right, the self.conv1. And that is just taking in the input channels, right? So the images that we're going to be actually having go into this are all in grayscale, so they're all black and white. So we only have one channel. If it was in color or if it was in certain types of colors, then you'd have slightly more. All right, and then 32 is the number of output channels. So you saw the in channels are 1, the out channels are 32. And these are also called filters. So we're actually getting 32 different feature detectors from the image. And then the kernel size just defines a 3x3 filter. So the filter is just scanning the image with 3x3 sections at a time. And this sort of box or this filter is moving 1 pixel at a time, is what the stride is saying. And then the padding being 1 is just adding a border of sort of zeros around the image, so the output size remains the same size as the input. And there are some really good videos out there explaining how convolutional neural networks work. That's sort of what's going on over here. Again, it is just scanning through the entire image. It is a black and white image, and it is essentially trying to figure out what features are where, and then training the model based on that. And then we'll get to the second convolutional layer, which is self.conv2. And you can see that the numbers are slightly different. In this, it's just different because it takes 32 feature maps from the first convolutional layer. And that's the number of input channels. Then it's actually learning or trying to learn deeper features. So it actually is giving you 64 as a output channels. So 64 different feature detectors as opposed to just 32. And this is just learning 64 different ways to analyze the features that are extracted from the last layer. That's essentially what it's saying. Um, so for questions, what does conv mean? So conv is just the convolutional layer. And essentially, this class we created is extended the deepNN method from torch.nn. So we are creating a deepNN class, and that specific class is creating this neural network specific to what our use case is. And then Sahil asked, what is the difference between convolution and the pool layer? So the pool layer actually is the next part, and this is a max pooling layer specifically over here. This is just reducing the spatial size of the feature maps over here. So you have the different parameters, right? For the kernel size being 2, this is just taking a 2x2 patch of the image, right? And then it is moving 2 pixels at a time. So this is just reducing the image size by half essentially. And we have this so that it reduces the computational cost and it just makes the network more generalizable, right? So it keeps the most important features instead of having to worry about uh, it only training or training very specifically on the data that we give it. This is a good way of, first of all, reducing computational cost because it's having the image, and then also by making it more generalizable so it's not focused or laser focused on specific or being pixel perfect, right? So that's sort of what the difference is. The convolutional layer is more so for trying to really learn what's going on. So it's taking in the feature maps and trying to learn what's happening. And for that, it's actually zooming way in, right, to what's going on. And then the pooling layer sort of zooms out and says, okay, now I have the information from all the different ways to analyze the features. Next, I want to make sure that I'm not over analyzing it on this specific input. So it takes a step back and it's like, okay, now I'm going to take 2x2 patch of the image over here. We could have actually changed it to like a 3x3 patch or something as well, but because the images that we're using are of lower quality, right, we're going to keep the kernel size at 2. But if there were much higher quality images, then we could actually increase it significantly depending on what the size is. Good questions. Then we have our fully connected layers, right? So those are sort of also known as dense layers. Those are just taking in the input size, which we get after the 2 convolutional and the pooling layers, right? So 64 is from our second convolutional layer. And then from the pooling size, we're getting 7. And then um, the images that we're using are actually going to be 28 by 28 pixels. And then the first pooling layer is basically reducing them to 14 by 14, because you remember it's taking a 2 by 2 of the entire thing, and then it does 2 pooling layers. Or we actually only have 1 pooling layer. We could have 2 pooling layers. If we had 2 pooling layers, then it would reduce it down to 7 by 7. So it is, again, much significantly fewer neurons, and then you end up with about 128 neurons in this specific layer. All right. And then for the out features over here in the second FC2, right? That's just saying that we have numbers from 1 through 9 or 0 through 9. So these 0 through 9 numbers are what are going to be our features that are coming out of this, right? So you have 128 features that are coming in from this first connected layer. Then from our second connected layer, we're going to be sort of reducing it down to just the 10. So we have 0. Okay, is this number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? Or 9, yeah. And then after all that, we just have our activation function. So that's sort of just introducing nonlinearity, and it's mostly to prevent the vanishing gradient problem, right? So it just, at a very high level, it just helps deep networks learn better, and it speeds up training compared to some other activation functions. So hopefully that all made sense. Again, if you do have any questions, this is pretty important. This is like machine learning or AI 101. So I do recommend, if you don't understand it, do a deep dive into it and figure out what's happening. And again, I am here to answer any questions, so do let me know. We have another question. What does the channel attribute mean? The channel attribute is essentially like the outputs, or the inputs and outputs. So in this case, you can see we're getting an input of sort of one image, and we want to break it down into sort of 32, which we want to learn almost 32 different attributes of this. And then we're taking the 32 attributes that we learned in this first convolutional layer, and then we're trying to learn 64 things out of this, right? So that's sort of what the channels themselves are. Good questions. All right. Then we have our actual forward function, right? This forward method is just sort of defining how this data flows through this network, and we're automatically calling this when we pass the data through the model, right? So we don't need to worry about that part too much. But again, what this is doing is you have the first pooling layer, right? So the image is basically being passed through the first set of 32 filters, which is the conv1 part of this, right? You need to look at it from the inside out. And then we are activating the neurons using the ReLU function. And then we are just reducing the size of the image. And then we do the same thing basically for a second time. So we're applying the 64 filters, activating the neurons, reducing the size further. And then next, what we're basically doing is we are taking the convolutional layers, because the output is sort of 3D feature maps, and then we're flattening this into a one-dimensional vector before passing it into the fully connected layers over here. So all we're doing here, right, in this sort of x equals this x dot view, x size 0, -1, is just reshaping x while keeping the batch size unchanged. So we're just doing a reshaping over here, flattening all the data from 3D to 1D. Then we have our activation, our first fully connected layer actually. And what's that doing is just activating the neurons and applying the first dense layer. And then we have our final output layer, which is just passing all the process information to this last layer. And again, this one does not have an activation function because PyTorch sort of takes care of that on its own. So you can see when we're returning x at the very end, the output is going to be a tensor of size, whatever the batch size is, comma 10. So the 10 is basically just, again, representing scores for each digit from 0 through 9. All right. So again, at a very high level, we're just getting an input of the 28 by 28 grayscale image, right? And then we are passing it through our first convolutional neural layer, which is taking a 3 by 3 filter and getting 32 filters out of it, and then reducing that to a 14 by 14. Then we do that again. We have 64 filters, reduce it to a 7 by 7. Then we flatten that 3D tensor into a one-dimensional vector, and then we pass those through our activation function, and then we end up with 10 neurons for all the different digits. So that's really the most complicated part of this entire thing. Everything else is very straightforward, very simple, but that is essentially how the neural network over here is working. So I'll ask a really good question. If we have more layers, does it always lead to better results? Not necessarily. So there is a point where if you have too many layers, you might end up actually either overfitting to whatever data you're giving it, or you just will not or it's just diminishing returns after a certain point. So you're just using extra power, processing power, extra compute power for very, very little gains. So it sort of tops out at a very specific point, and then depending on how you were able to implement your layers, you either would have a good model at some point, but then every extra layer that you add to it sort of just keeps flattening it out. It doesn't really have too much of a difference. It doesn't make too much of a difference in the quality of the output, or it just overfits to whatever you have currently. Great question. Okay. So again, that was like a really, really quick crash course on some simple machine learning. Um, let's see, it is currently 2:45. Okay, I'm thinking we would take a quick 10-minute break, and then we can reconvene at around 2:55. And again, if you do have any questions, let me know. But again, this is really the majority of what you need to learn if you do want to go into AI or machine learning, is just all of this. So, all right. Once again, we'll be back in about 10 minutes. And then we will move on to the next part of this, which is really training this model and seeing how it works on the GPU and how it works in the cloud. In the meantime, if you do have any questions, please do put them in the chat, right? And I will answer them all once I get back. Um, so I'm asked what happens at each layer. So I did just explain what happens at each layer. I would recommend you can go back a little bit if you're watching on YouTube or on Twitch too. I'm pretty sure you can scroll a little bit further back and see the explanations for what goes on at each layer. All right. And I'll be back in 10 minutes. So that's, I think, a perfect time to check that out. All right. I will see you all at 2:55 p.m. my time, whatever time it is, 9 minutes from now for you. I'll see you then. All right. Okay, I am back, and I know it's a little bit early, so we'll give it a few more minutes for other people to get back. But in the meantime, I'll just be answering any questions that you all might have in the chat. All right, let's check out what's been going on. It looks like a lot of stuff. 404 not found. Hello again. You're waiting for your uni results with MLH in the background. That's good. Hopefully everything goes well, right? Hopefully you passed everything with flying colors. Um, Currently 2 a.m. Wow. That is that's a lot. Up at 2 a.m. watching MLH streams. I love that. Hey, if that's not a reason to get in somewhere, I don't know what is. Um, and you are starting your bachelor's as well. That is good. Okay, looks like I need to connect my runtime back. CS in bachelor's. Favorite pizza topping? Let's see. My favorite pizza topping. Honestly, I'm gonna say olive. Olives are a good pizza topping. I feel like it adds that like not saltiness, but it adds a little bit of something, to the pizza, a little bit of flavor. Uh, Black olives. So I'm saying pineapple. That's hilarious. I know that's a very that's one that divides a lot of people. All right, 404 agrees. We got 404 approval. Olives being good. Love that. Add cottage cheese cubes. I actually have had uh, pizza with cottage cheese. That is actually pretty good. You're right. Did I have that? I think I did have that in India actually. All right. Looks like it is now 2:56, so that is past time. So we will continue now. It looks like my runtime got disconnected. I can always reconnect it. It's not a huge issue. And then we will continue with our coding. Okay. So last we left off was in our, what is this? Deep neural network. And so hopefully you all were able to understand what's going on here specifically, right? Next, I want to actually take a look at our data set because I think it helps to see that before you actually get into coding, right? So let me see, I might have to download this. Okay, so I guess we will try and see if we can, I'm trying to find like a raw version of this so we can actually see it online. But all right, let's try this. So you can see that the data set that we're using, this is on TensorFlow specifically, but it is a database of handwritten digits, right? This is the home page. Let's see if there's anything going on here. But looks like no. But essentially what this looks like is, again, you have a training and testing split. It is a pretty large data set. But this is essentially something like what it looks like, right? So you have all of these different images and they all have labels, right? These are essentially just images of handwritten digits. Yeah, so we are using the MNIST data set or MNIST, whichever one you want to call it. But again, so these are all the different numbers, right? So you can see that not all of these look the same, right? A 1 over here is not the same as a 1 over here, which is not the same as a 1 over here. Some sevens look different, right? Some sevens have a line through them. Some sevens do not have this through them. So this is the data set that we will be working with. Don't worry about how we're going to get it right now. We'll be doing that all in the code itself, so it should not be an issue. But I just wanted to give a quick overview of what data set we're working with, how it looks like. Um, okay, so we can go back to our model over here, and let's see, any questions for pronounces MNest. Yeah, some people pronounce it as MNest. I think that's the easier way to say it instead of MNIST. It takes a little longer. Um, but yeah, this is essentially, that's the data set that we will be using to, or for this right now, just because I think it's a very easy to use data set, very easy to visualize, and it's much easier to understand what's going on, specifically in this sort of model right here, right? So when I mentioned that, okay, we have an input size of 28 by 28, you could see that the pixels over here are actually 28 by 28 pixels, and that is what's creating those images. 404 is absolutely right. This and the Flower data set have jump-started many careers in AI and data science. Absolutely. I think this is like one of those classic data sets that almost everybody touches at least once when they're learning how to, or anything AI or ML related. Okay, now we can actually move on to, let's see, let's try and run this actually, and this. So it looks like everything runs perfectly fine. Next, we actually want to visualize our model, right? So we have a model over here. Let's actually see what's going on. So I'm going to quickly write a model visualization function, and you can or you don't have to make this, but I think it is useful to actually see what's going on behind the scenes in this model, right? So visualize model. Did I spell visualize wrong? I did spell visualize wrong. Visualize model. And over here, we just have our device. Wow, my keyboard is not helping me right now. Torch that device CUDA if this is available, and then model is dbnn.to device, and then we just want to get a summary of the model 12828. Okay, perfect. So it looks like this was able to generate everything that we needed, and now I'm just going to call the visualize model function, and this should output exactly this. So this is just a visualization of the model, right? And this is just showing us what's going on behind the scenes. So for our conv2d layer, the first one, this is the output shape, uh, the number of parameters, then we can just see exactly what's happening at each step of the way. And what it looks like, this is the number of total parameters, the trainable parameters. We don't have any non-trainable parameters. So um, our forward backward path size is actually really, really small here because we are working with very simple images, right? 28 by 28 is not something that you need to stress out over. And then you have the different parameter size and the estimated total size over here. So again, nothing fancy going on, just some really, really simple machine learning. Okay. So now that we were able to take sort of a look at what's going on behind the scenes, next we can actually get our data loader. So let's do that next. So let's make our data loader class. So I guess I can scroll this all the way down. Get data loader. And for this, we have a batch size default of 32. Train equals true. In this case, transforms.compose to tensor and normalize, yes. Then we also have our data set, and this is where we're getting our data set from. So MNIST, okay, this is all already here. That's perfect. It is able to figure out exactly what I want. transform, train is train, data, and then we have our data loader, our data set, our batch size, and whether we are shuffling this, we do not need it to be shuffled, but we do want to specify a higher number of workers and pin memory. And then we're just returning the data loader. Okay, so this is what is going to be downloading our data set, and we don't need to download it immediately. We'll just call that in a separate function. All right, so next up, we're going to actually be training the model, right? So let's write our train model function, train model, and over here, we're going to have equals 5. Let's have 5 epochs. And then we don't need to specify learning rate. You could if you wanted to, but because this is, again, a much simpler data set, it shouldn't be an issue. The device and model, and then train loader is get data loader, and we can just leave it with its defaults. Then criterion is going to be the cross entropy loss. We have an optimizer of, let's use the atom optimizer with the model parameters. And over here, we're specifying our learning rate. And then we have using a grad scaler. Perfect. And then you can actually run this for E in range epochs. We can have for images and labels in train loader, images and labels to device. Let's do non-blocking just in case. And then we have our optimizer with AutoCast using CUDA. And we can specify this here just because we know that we're going to be running this on a GPU. But if you didn't know if you had GPU access, then you would generally leave that out. Outputs model, and we have our loss with the criterion of outputs and labels. Then we're scaling it loss backwards. We are step using optimizer and then updating it. And then we can just have a quick print function over here saying that, okay, we are at this current epoch with this specific loss. And then we want to actually save the model, and we can print out that we've saved the model as well, so we know that it's been saved. All right, so this right here is essentially what's calling everything, right? So this is going to call our data loader. We're going to be able to download everything as well, and we can honestly just start training the model right off the bat then, given all of this. So for that, all you need to do is write train underscore model, and then write the number of epochs you want it to go through. 5 is a default. I'm going to go with 10, just because why not? So this is going to start with downloading the data set. It may or may not struggle trying to find it, but it should find it eventually. And then once it finds it, then it will start actually doing the training portion. So let me scroll this back up here so that you all are able to see it. And then we should have it training when we get back down. So again, to answer the previous question on how we get to the data set, You shouldn't need to get to the data set. We already did import it for download. If you want a direct link for the data set, here's one on TensorFlow. So you shouldn't need to, again, download the data set or anything. We are downloading that in the code itself. But if you wanted to take a look at the data set, play around with it, that's a great place to check it out. So you can see, okay, so it was able to download it over here. So it was able to get all the MNIST photos off of here. And you can see that it's starting to actually train. It's 3 epochs in, and honestly has a pretty good loss rate so far. So it looks like we are doing good. Okay, yeah, no other questions. And I'm going to move myself. I'm going to move myself to the other corner, but it's not letting me. Okay, now I'm behind the screen. Okay, I'll just stay behind the screen until you all are able to get this, and then when we move on, I'll bring myself back up. All right, 404, thank you so much for joining while you were here. Hopefully you get good uni results, so good luck with that. And yeah, hopefully I'll see you at one of the future streams. All right. Okay, so we are currently training the model. Hopefully you all were able to get all of this. And we are at 8 epochs. It looks like we have a pretty good loss rate. It's fluctuating quite a bit. Whoa, this went up to 8 for the loss. Oh, E minus 0.6. Okay, so it was not up to 8. It's basically 0. All right, so we have a very, very high, low loss rate. That's looking good. Might be overfitting with 10 epochs, actually. I think at this point it looks, well, there's only one way to find out. We'll see what the accuracy is when we run some tests. So we were able to save the model. All right. And we should be able to see that in our files. Yeah, so we can see we have our model.pth over here, and this is essentially our machine learning model. Let's see. So Silver Acid asked, what does the loss rate mean? Sorry, you might have missed it. So the loss rate is essentially used to measure the model performance. So it's basically seeing how good the model is actually working. So it just calculates a deviation of a model's predictions from the ground truth predictions, right? So how different is the ground truth prediction from whatever the model predicted, and then the more different it is, the higher the loss, so the less accurate it is. So again, if your predictions are completely off, then you're gonna have a much higher number. If they are really, really good, then it'll have a lower number. Ours seems to be extremely good. We're at like 0.000007 or 1 over here other than this last one. So it looks like we're doing pretty good. We have a good loss value. Good question. Can I scroll up? Absolutely. Okay, so again, after this, we'd just be testing the model and seeing what the accuracy is on some, on some inputs. We'll see how many correct we have and then how many total, and we'll just do some math. And that should be able to tell us what our test accuracy is. So we will actually be able to test this model. We're going to write our own custom test function for it. Just so we're not, we're not just believing what this number outputs blindly. We're actually going to put in the legwork. All right, and pepperoni pyramid, let me know when you're ready to go, and then we can keep moving. And give it a couple more minutes, and then otherwise we'll just keep on moving. And you can always pause the Twitch stream or the YouTube live and then catch up later on. Okay, awesome. Ready to move on. So we were able to download our data set over here. You can see that this is our data in the MNIST. Okay, we'll probably be able to see everything in here. Yeah, these are all the different images, big, like, zipped packages over here that contain all these images, because obviously you don't want to download huge files or a ton of small files. Single larger files are easier to transfer, so that's why it is in this specific format. But if you did unzip them, you'll be able to see all the images in there. Okay, next up, let's move on to the testing part of it. So let's do a test model function. And for testing, again, device is CUDA, send this to the model, load state dict. So we're loading the model path, map location. Location is device, yes. And then we have our eval, we don't need this, test loader. So this is just evaluating it. Then we want to do the test loader, which is getting the test loader. We're not doing any trainings here. We already have our trained model, so we're going to set that to false. And then we just want to do a little bit of simple math, see how many correct we have, see it out of the total, and then for each of the images and labels in the test loader, we are going to send them all to the device, and then outputs to model images. Total. Okay, perfect. So this is just seeing which one of these is larger. Total plus equals label.size, adding the labels to the total, seeing how many of the correctly predicted items there are, and then it's just checking the accuracy using a quick percentage of correct over total times 100. So again, very straightforward. Honestly, Gemini was pretty good over here. It was able to figure out exactly what I was trying to do and output the code for it. All right. And then we can actually try and test the model. So test model and run this. Let's see how well we did. Oh, no argument, map location equals device. Torch.load. Oh, this is in the wrong place. The model path is on device. Okay, there we go. That should hopefully fix it. And it did. All right, so we have a pretty good accuracy of actually 98.94%. That is a good big number. So we have a really accurate model over here that we created, right? And again, you can always go and tweak some of the model parameters, see if there's anything that you can change that makes, makes the model more accurate, less accurate, whatever it might be, right? You can change the number of epochs. So see if you try and run this like 5 times, try and run it 20 times, see which one gives you more accurate results. All right, and you can see over here that we did have initially, when we were looking at this, we had a size of about 2.26 megabytes of total size. And you can see that in our GPU specifically, seems like it's at 0.2 after running. Interesting. In our system RAM, also 2 gigs. So again, if we had a much more complex model or a more complex sort of deep learning algorithm, then all of that would have been reflected in sort of our GPU power and compute. Okay, so we were able to test the model, right? And we saw that it is a very accurate model, which is good. That's what we were going for. Then we actually want to, let's say we wanted to visualize our predictions, right? We wanted to actually see what does this look like, right? What image is it doing predictions on? So visualize, do predictions. And then hopefully Gemini is able to pick up on what I'm doing here. Yes, model to device, model path, map location device, and eval. Then we have our test loader. So again, a lot of this is just repeated stuff, right? I think that's a majority of machine learning or any sort of AI stuff is really just understanding those algorithms that I went over in a lot of detail earlier, understanding what's going on behind the scenes. Then after that, a lot of it is honestly just repeated work. So we can see that a lot of this stuff is just the same thing that we did earlier. Uh, Images and labels of our next test loader, images to device, labels to device, outputs, our models. This is all correct. Just CPU.numpy predicted. Your axes are the plt.subplots, and we're gonna have 4 by 8 because I think we have 32 outputs over here with a 10 by 10 figure size. And then for I in axis, enumerate axes dot flat. Let's do image is numpy.squeeze images. So we're getting rid of all these one-dimensional entries, and then show images and CMap, so color map of gray. So this is in grayscale. We can set title of predicted item and actual prediction. And then we don't need axes. So off, oops, off. And then show. Okay, hopefully this all runs without an issue. And let's try running the visualize predictions. Let's see what we come up with. Okay, perfect. So, ooh, looks like the titles look really bad right now. Let's just go with actual. We don't need, or no, we don't need actual. We just need predicted. We can tell what the actual is because we are actually humans. Okay, so this is going to tell us what it predicted, and we can see what the actual one is. So you can see that's actually very accurate as far as what this is, right? So we have 7, 2, 1, 0, 4, 1, 4, 9. Looks like all these seem correct so far. 0, 9, 6, 0, 9, 5. And this looks like it was a more difficult one to figure out what it might have been as well, right? You could have mistaken this for a 6, but it was able to figure out that that wasn't the case. Also had a random sort of blank area over here. So it's pretty interesting to see how well this was able to figure out what's going on. So you can see over here, this is a 3, right? If we had maybe a larger filter size, then it might have been less accurate. It might have actually mistaken this for an 8. 4, 9, 6, 6, 5, 1, 3, 1, 0, 4, 7, 0, 4. So okay, we can see that the predictions are all actually very accurate. So the or the model that we came up with is actually really good, and you can see that right for each one of these has or it's about what 98% accurate, I think is what it said. So I think only on the most like diabolical sort of handwriting, right, the ugliest handwriting is the only one that it wouldn't work with, and everything else it actually does pretty good, right? So that's impressive. Very impressive for what it's doing. So I'll leave this up for a little bit longer, right? So you all can also, and honestly, let me erase this predicted part. We know that's what it's doing. That should clean it up. So all we have is the number above it. Yeah, and this should tell us exactly what it's trying to predict without a bunch of overlapping text in the way. So yeah, this is actually a very impressive model, right? And we can honestly tweak some of the hyperparameters as well. So I want to ask you all actually, make this slightly more interactive. What do you think we should tweak over here and see what will change if we do make those tweaks? And we'll give it a little bit more time for you all to finish writing this if you do want to do that. And then do let me know in the chat though what you think could be changed in the model or in the training, um, such that we might get a more accurate or less accurate result, because it might be interesting to see. So if we trained it only once, maybe how would it compare? What would the accuracy be versus if we trained it like 20 times or 50 times? Right. So all these things are really just things that you need to tweak. You can also do that on your end. It's just figuring out what the different hyperparameters might be and how that might work. Okay. And do let me know when you all are done and are able to see these predictions on your screens as well. Yeah, it was able to get the 5, which is very impressive. Okay. All right. We'll give it maybe a couple more minutes. And let me know what your results are, if they're the same, if it got any of them wrong for you, or if everything worked perfectly fine on your ends as well. Okay, so you all were able to hopefully complete all this and are able to see what's going on, right? So basically we chose our specific cloud service. In this case, we use Google Colab. I do want to show a couple of other examples of other cloud services, right? Because it might be interesting. But at a very high level, just want to quickly review what we did was we obviously installed any dependencies that we might have needed, right? We made sure that we had a GPU available, so we know that we had or we were using our T4 GPUs. Then we actually built our AI model and then trained it, and we went over all of that in a lot of detail. Then prepped our data set, right? So we got all the data set from the internet, and then we trained the model using our cloud GPU. And once we had that, we were able to actually evaluate the model and see what was going on with it. So we were able to see how accurate it was, see it, and then we were able to do a quick visualization of, okay, this is what's actually going on behind the scenes. All right. So now actually what I want to do is show you all how this exact thing might work um, on a cloud GPU provider. So currently the one that I'm using is going to be RunPod. Let me see if we can share this tab. Okay, so this is sort of a very high level of what RunPod looks like, right? This is my spend rate, about 22 cents an hour, about 14 cents a day for the last, I think, month or so. I think this was all because I had something open and forgot to terminate one session. Um, but and I spent a lot, just working on this specific project today. But this is the pod that I have currently, but what we could do over here, right, is deploy a new pod, and you can see that there's a huge, range of options over here, right? We can try training this on an H100 for $3 an hour. I don't know why we would want to do that, but you could if you really wanted to. I would probably reserve that for something with a much more difficult or more challenging use case. Um, we can go with an A100, an A40 maybe. So in the instance that let's say we wanted to use an A40, yeah, let's use an A40. We can use let's do spot. I don't really care if it's on demand, right? It doesn't have to be non-interruptible. And let's start this Jupyter notebook and honestly just copy paste everything that we had going on earlier. And again, this is another example of a cloud GPU provider, which basically lets you run AI models in the cloud itself. So this over here is going to build, might take some time. Okay, and let me actually stop this one. Terminate this pod, connect to this one right here. And we have a ridiculous amount of RAM, 50 GB RAM on this. So interesting. That should be plenty for our use case, right? So we can just connect to this, and what I'm going to do is just copy paste all the code that we had earlier into here. Okay, so this is going to take a second to load, and we just want to open up a new notebook over here, and then copy everything we had earlier over. So let's do that. Um, add all these import statements, add our deepNN class. We can do visualization over here as well. Why not? And then getting the data loader. Training the model. And then testing our model. We wrote a lot of code. I guess AI wrote a lot of code. We double checked the code to make sure it was accurate. Visualization and visualization. Okay, so let's run this. I think I might need to download a bunch of stuff. Yes. Matplotlib. Yeah, let me do all that now. I am just trying to get this pip install command. Okay, that should hopefully be everything we need. Was it able to run properly? All right, I think it did. Okay, so again, we are just now um, running through this, and let's see. The model visualization is the same. Yes, that's good. And let's actually try and train this. And number of epochs, let's up this to, honestly, up this to like 20. And then see if hopefully this shows up on our So you can see over here, I'm going to switch back to this. It's currently or about to start training, and you can see that the GPU utilization is for some reason still at 0. CPU is still pretty high, but the GPU memory you can see is starting to creep up, right? We're currently at 1%, which does make sense. We have a massive GPU memory, right, of 50 GB, but it was able to use a little bit less than, I'd say, half of that with around 200 megabytes. So you can see that, okay, right now it's doing a lot of CPU work, but this is sort of how the model itself is being trained right now. So right now it's at 5 and the loss is currently just going down. Not sure why this isn't using the GPU right now. Interesting. I'll have to do a little bit more debugging. But again, this is an example of sort of how this would look if you were to run it on a cloud GPU provider. Okay, there we go. I think it's starting to use the GPU now for some reason. So this is again an example of how it would use a cloud GPU provider that isn't necessarily just Google Colab. I know that's the default that a lot of people go for because that's one of the easiest to use, or that is the one with the most generous free tier that you can use their T4 GPUs. But again, if you wanted to use something more, or if you wanted to do something more computationally expensive, or you just wanted to, play around with other models maybe, then this would be the perfect way of doing so. So let's see actually how many this actually went, and you can see a lot faster than our previous one, right? We're already down to 14 epochs versus I think it was still running the first 5 or so on um, the T4 GPU. So you can see that this is again works significantly faster as well compared to our other GPU because we're on a more powerful one. And then when we actually test and visualize it, let's see what the accuracy and what this thing looks like. But again, that is at a very high level, sort of how you can run and deploy your AI models to the cloud. So that is basically what we just did, right? We trained our AI, we wrote our AI model, we trained it on on a data set that we pulled off the internet, and then we deployed it to the cloud. And this is what we have now, right? We have this model that just got saved. And let's try and run a visualizer. And everything looks like over here again that it was correct once again. So yeah. All right. Do let me know if any of y'all have any questions. That is pretty much it for today, right? It was a pretty pretty chill hopefully stream that you learned something in. Um, Again, there's a ton of opportunities here. You can do a lot more than just this. Again, I do recommend you all go out after this and try and train your own AI model. It doesn't have to be on this specific data set. It can be on any data set of your choosing, and really just understand what's going on in this right here. So this is deep neural network class, and figure out what's going on here, why everything works the way it does. There's some really good videos online that will help explain it to you as well. Yeah, so I will now leave this time for any other questions. Do let me know if you have anything. Pepperoni Pyramid asks, will I be sharing the entire code? I absolutely can share the code. Um, I will upload that to the GitHub. Actually, I have a Google um, Colab workbook. Let me just share the workbook. But yeah, I'll share the workbook in the Discord chat, so you all should have access to that. So don't worry there. Silver Acid. Thank you for joining. Yeah, I know. This time I didn't have a single mess up with the screen shares. Got it all down, so I'm very happy about that, right? Thankfully, the screens were all being shown when they were supposed to be shown. So that's good. And hopefully we'll keep that momentum going. But yeah, I do have another stream coming up tomorrow. That'll be today in Global Hack Week. So if you all do want, I'll see you all there. Otherwise, there's another one on Monday as well, and that should be a pretty interesting one as well on running CI/CD pipelines. So if you are interested in that, highly recommend checking that out. It's something that's highly used in the industry. So if you are interested in, just learning about all of these tools and technologies, definitely recommend you come out to that. So what resource I recommend to learn more about this? By this, I'm assuming you mean like the whole like neural network part specifically. Honestly, I would recommend there's a lot of good YouTube videos out there that have some insane visualizers. So I know one really, really good resource is Three Blue, One Brown, I think it is. He uses this crazy visualization, this Python visualization library that I also actually gave a workshop on was an intro to Manim. So Manim is the tool or the library that he uses to code up all those visualizations in Python. It's pretty interesting, but I would recommend definitely checking his videos out. He has like an intro to neural networks that actually uses the same MNIST data set, and he'll really show you what's going on in the neural network while it's going through that entire process. So step by step by step. It's pretty enlightening. I would highly recommend that, especially after this, um, especially after this workshop where you really learned about it. Let me see if I can find it. Blue, one brown, machine learning, because it's I think right after this, because it's very relevant as far as this specific data set and everything else. It should be like the first thing that you see. It's but what is a neural network? Deep Learning Chapter 1. That is the name of it. Copy that and paste it to here. So definitely check out, I'd say this video. It is also, again, using the MNIST data set. So the fact that you used it right now will actually get you ahead. And I did explain it a little bit, but when you see it sort of visually, it helps a lot more. So would definitely recommend that as a next step. Maybe right after this workshop, you can dive right into that one. Again, it's not a very long video either. I think it's only around 20 minutes. So definitely check that one out. All right. I do want to bring your attention to some other sort of cloud technologies that are also available, or cloud tools. There's Google Vertex, which is a very popular one. Their Vertex AI platform, which is technically which uses Gemini, but it is more for like enterprise models, so really, really large scale models. Unfortunately, that does require you to add billing to your account, which I still have not done from yesterday in Google Cloud, so won't be able to do much there. But uh, again, that has a ton of like cloud storage and their specific AI machine learning models where you don't need to put in too much effort in actually creating those. That's one. Then there's also some others from Amazon, Microsoft as well. It really depends what you want to use, what your use case is, and obviously do like a comparison on pricing, see which one, which ones are more expensive, which ones are cheaper, and which ones are best for you. Scroll this down to here. Okay. Do I prefer PyTorch or TensorFlow? I'd say I prefer PyTorch just because I'm a lot more familiar with it. I think that's what most uh, researchers or most people in academia use PyTorch because it is also, or I guess they're both open source, but that's just the one that is used more often, and it's the one that I use primarily for my master's program. So just because I'm more comfortable with it, I tend to use PyTorch significantly more. And I think the documentation or the amount of information about PyTorch on the internet is higher than the amount on TensorFlow. Um, in industry, I can't say for sure. I think they are pretty close together, but most likely PyTorch is being used a little bit more in industry. But honestly, as if you know how to use one, it's very, very easy to pick up the other. Like very, very easy. You should have no difficulties with it. It might be some like syntactical differences or some small issues that they're like those things that you end up spending a lot of time on, but they're really small, so you sometimes miss them. But again, it's nothing too major as far as the differences between PyTorch and TensorFlow. Good questions. Yes, knowledge availability is for sure. That's also the same thing for me, and I think that's the case for a lot of people, right? So it sort of just fulfills itself in terms of more and more people learn about it, so more people post about it, which means there's just more information about it, and then the gap between maybe two technologies just keeps on expanding because of that. But yeah, that is absolutely true. I think the same for me. Knowledge availability is absolutely a determining factor. And even if you are using like I don't know ChatGPT or some other AI tool to help you learn, um, the amount of data that is available also has an impact on the quality of the reply of the model, right? So the more content or the more knowledge availability, which I think is a really good way of putting it, is available on a certain topic, right? The more data the specific model has that was trained on that topic, so it knows a little bit more about it. So that's also something interesting to think about is that's not just the case for you. That's also the case for, I would say, like chatbots, right? So if you just hold a chatbot to, hey, make me like a machine learning project, then it would actually probably skew towards using a resource that has more knowledge available on the internet as opposed to one that's maybe a little bit more obscure or has less information about it. That's it's an interesting point, I would say. All right. Honestly, that is pretty much it. We do have a little bit of time though, so again, if you do have any questions, feel free to keep them coming in the chat. There's a lot of good information coming in. Um, but again, this was the title of the three blue, one brown, video that I recommend you all take a look at is, but what is a neural network? And it's a really good introduction to neural networks. And again, because it uses the same data set that we just worked with, you'll have a little bit more of an idea of what's going on. And if you want to, you can also figure out how to do animations in Manim, which is the animation language that the YouTuber uses. And that is a separate video that is also on the MLH YouTube. That was a separate stream, actually. So I would also highly recommend you all check that out. But okay, if there is nothing else, I will say that before you all go, um, there is a mlh.link. There is a link I need to send you all. And again, this is just MLH looking for feedback as far as Global Hack Week. Again, Global Hack Week only happens because of the hackers, not because of me or any other streamer. So I do recommend you all fill out this feedback form and just say, hey, I think Global Hack Week is great, or I think it's whatever you might think about it, what else you might want to see. That is definitely something I would recommend taking a look at. Okay. Other questions? For practicing and learning, what qualities should you look for in a data set? It really depends on the data set that you're, okay, it really depends on what the end result is for your, whatever you're trying to make, right? For practicing and learning. Sometimes you can actually create your own data sets. I find you learn a lot actually when trying to create your own custom data set. Uh, so I would for sure recommend doing that at least once. But if you wanted to use like online data sets, I would say just use like the popular ones. Those normally have like, high quality data or accurate data at the very least. So those are something to definitely look out for. Just, is it high quality data? Is it accurate data? Is the data cleaned up? Is like a maybe, right? You might want to practice or learn how to do data cleanup, or all the data pre-processing that goes on. That is also a very important part of the full machine learning process, right? I think most of it is actually just how good is the data, and then the actual algorithms themselves are not the most difficult part in the world. So the most time consuming and I'd say tedious part is absolutely just getting good data, or getting whatever data you have and then cleaning it up so that it ends up becoming good data that can be sent or can be put through a machine learning model. Good question. What tools am I using for the CI/CD pipeline lecture on Monday? So you'll have to be there on Monday for that, but I will be touching on Jenkins, which is a really, really popular CI/CD tool that's used across the industry. I think almost every single company uses Jenkins, but we will likely also be touching on the sort of GitHub Actions and the GitHub specific CI/CD pipeline, because that is a lot more accessible to everyone else, right? You don't need to buy any enterprise level software for that. So we're going to be doing a simplified version of a CI/CD pipeline, and we'll be touching on sort of the other options that are also available. Okay, if that is it, once again, I highly do recommend you all fill out this mlh.link/GHW feedback form. And again, if you have any questions, please do reach out to me on Discord. Just at me and I'll respond to it in the Global Hack Week channel. And yeah, all right. If that is it, then once again, thank you all so much for joining. Have a great rest of your day or a great rest of your evening. And I will see you all at hopefully one of the future streams. All right. Bye, everyone.